so this is Mr. Fortin's chemistry class, doing a lecture on mole to gram conversion. The stuff that we're going to do tomorrow is grams to moles and also to particles and stuff like that. And I'll have another video set up for that starting tomorrow. So with me today is my 4th period class. Everybody say hi. All right, good. Now shut it. All right. So let's start off talking about mole to gram conversions. So the way this is going to work, whenever we have, whenever we have a rate, which is what we have here, 60.5 miles per hour, we can write it like this, mph, or we can write it like this, 60.5 miles per hour. Now, if we want to extend that over, we can say that it's 60.5 miles per 1 hour. Now, why is that important? So if I just told you, hey, if I'm going 6 hours and I was driving 60 miles an hour, all you do to figure out how far you've gone is multiply those two numbers, right? Here's the reason why it works. Is because whenever I do this, set it up 6 hours, my hours cancel out, and I'm left with 60.5 miles. Now, the reason why I said let's start off with something easy is because this is going to set us up into what we're doing today. All right, let's try another one right quick. Obviously, what's the answer, guys? 363? All right, miles. All right. So if I have $75, how many quarters do I have? Okay. So $75. All right, we set this up. What's my conversion right here? What's my conversion factor? $1 is 4 quarters. There you go. $1 is 4 quarters. So 4 times 75 is what? 300 quarters. All right. So here comes something important. You need to copy this down. Now I'm going to explain this to you right quick, and then pause the video so that way you can actually see and copy this down. This is what we call the Molar roadmap. Alright, so the way this goes, depending on where you want to start from, if you want to start from grams, moles, atoms, you're going to use a certain conversion. If you start off in grams, you go to moles, you're going to do 1 mole over the molar mass. And then from moles to atoms, you can do 6.02 times 10 to the 23rd over 1 mole. If you start off in atoms, we're doing 1 mole over 6.02 times 10 to the 23rd. And if you go from moles to grams, that's molar mass over 1 mole. This is the one we're going to be learning today. Tomorrow we're going to learn this one, and we're also going to learn these steps right here. Alright, so go ahead and pause the video so that way you can copy this stuff down, and we're going to go ahead and move along. Okay, so hopefully you have enough time to copy all that down. If you don't have this paper in front of you, go ahead and copy down this problem. You can pause the video. So right now what we're looking at here is we have 3.261 moles of magnesium oxide to grams. Now, one of the other things that we need to make sure that we keep on refreshing is our ability to write down compounds, both ionic, acidic, and covalent compounds. So the very first step that we need to do with this is write the formula down. So on your paper, which you want to write down magnesium oxide, we're going to figure out the formula of it. That's Mg 2 plus O2 minus. We don't need to crisscross because the charges cancel out, so this becomes MgO. So our very first step is the formula. Alright, in all these problems, find the formula. Our second step, find the molar mass. Alright, so our molar mass for MgO is pretty straightforward. Mg is 24.31 grams per mole plus 16.00 grams per mole, and that gives us 40.31. I'm going to put it down here for a reason you'll see in a little bit. 40.31 grams per 1 mole of magnesium oxide. So going back to dimensional analysis. Now if you use something different, then use what your teacher showed you, but this is what I show my kids. So you make a T-chart right here. Now over here is our conversion factor, 40.31 grams of magnesium oxide per 1 mole of magnesium oxide. And if I start off with 3.261 moles of magnesium oxide, that has to go in the upper left-hand corner of the box. So 3.261 mole magnesium oxide. So we multiply by everything on top, divide by everything on bottom. Hey kids, what's 3 divided by 1? What's 3 billion divided by 1? 3 billion. Alright, so we don't really actually have to divide by 1. We just multiply 3.261 times 40.31, and we're going to get our lovely answer, which is going to be what? Alright, so here we go. Are we done with our answer? No. It needs to be grams MgO? That's it? Well, no, see, now we lost our grams over mole because this part right here is our grams per mole. Are we done? No, we're not. I'm about to reintroduce you to your old friend, sig figs. Oh, collective groan, right? Okay. So, for those of y'all that don't remember, alright, whenever you multiply or divide something, you're going around to the least number of sig figs. Least sig figs. Alright, and as a quick review, a sig fig is any number that is not 0. Alright, sandwich zeros count, so like 101, that's 3 sig figs. And then 1000 with a decimal is 4 sig figs. If I have 10.00, again, still 4 sig figs right there. Now, if I have something like this, 0.003800, I only have 4 sig figs because these are the only guys that count. These guys up here don't count. Those are leading zeros. They don't count. All right. So going back to this, how many sig figs? The other thing is, whenever we're counting up sig figs, we only count the stuff that is in the original problem. Okay? We don't count this part right here. All right? This part doesn't count for sig figs. That part doesn't count for sig figs. So in our original problem, we have 4 sig figs. Okay? So we're going to round this to 4 sig figs. So underline, circle. All right? 131.45. Since this number is 5 or greater, we're going to round this to 131.5 grams MgO. All right? So moving on to the next problem. So the next problem, convert 2.832 moles of calcium hydroxide to grams. So again, first part, up here, find the formula. Second part is to get the molar mass. Third part, plug it in. Alright, so over here we have calcium hydroxide. Calcium has a 2 plus charge. Hydroxide is OH minus. So we need to put parentheses around there because these charges don't cancel out. So our formula becomes the Intrepid Ca parentheses OH parentheses 2. So that's going to affect how many atoms we have. Ca has how many atoms, class? O has how many atoms? And H has how many atoms? It's going to be 2. This right here distributes to each one of these guys in here. It's just like if I had the equation 2x plus 6 in parentheses, that would be 2x plus 12 because I'm distribute this whole thing out. Alright. So, I take this. So if you're having a little bit of problems with molar mass, this should help you clarify a few things. So what I'm going to do is I'm going to take the mass of calcium, which is 40.08, plus 2 times 16, plus 2 times 1.01. Now, why did I do these 2 times? It's because what this formula is telling me is that I have 2 H's and 2 O's in my compound. And in order for me to get the right number in my gram form of the mass and the right number overall, I need to multiply this 16 by 2 and this 1 by 2. Not add, multiply. Alright? So once I do that, class, what does my gram form of the mass come out to be? 74.1 grams Ca OH2. Sorry about writing on a slant. Alright, over 1 mole CaOH2. Now, what happens next is I get my original. This is the problem of doing it during fourth period. Anyway, I get my original number, 2.832 mole CaOH2. I plug this in, and now I solve. So this equals some number. It's going to equal 209.85 grams CaOH2. But I'm not done, because what else do I need to do? Sig figs. Alright, so 1, 2, 3, 4, rounding to 4 sig figs again, becomes 209.9 grams CaOH2. Alright, hopefully that clears things up a little bit. We're going to go on the next problem, and you guys, that's pretty much all I'm going to do for today. So if you don't understand it, if you're still having problems, you can message me on Facebook or email me and through Edline, and we'll try to figure it out. So yeah, have a good time.